Hi, and welcome to paper 2 of the 2021 Leave Cert Ordinary Level, and this particular video is on question 2. Okay, so if you want to copy the notes, don't forget to send me an email at shanetry@gmail.com, and if you like the video, just subscribe to see access to more playlists. So let's get stuck in. So question 2 here, first impressions, it's a probability question, so let's get to read it. At a stall in a fun fair, the probability of knocking a coconut off its support is 0.34. Okay, so look, I'm going to try to get some marks here. So the probability of now knock off, okay, is equal to 0.34. Might get you something. Okay, just acknowledging that the probability symbol. And then what is the probability of not knocking a coconut off? Okay, well, probability can only score between 0 and 1. So you're looking for the difference between 0.34 and 1. So you're taking them away. Use the calculator to do in your head. I think that's 66. So 0.66. So there's a fairly, if you want to make them percentages, there's a 34% chance of knocking it off, a 66% chance of not. Remember, percentage is just multiplying by 100. So 0.66 by 100, you can see that that's 100, is equal to 66%. And that's all percent means, per 100. Now, we don't generally talk about probabilities in percentages, although it is useful to think of them like that. But we always need to remember that probability score between 0 and 1. 0 is impossible, 1 is certain. Okay, and most probabilities are somewhere in between that. So that's it. Okay, so 0.66. Make sure your work is clear, lay it out, make the answer obvious. So part 2 then says David is given 3 attempts to knock the coconut off its support. What is the probability that he knocks the coconut for the first time on his third attempt? Give your answer correct to three decimal places. It's not important yet. So I would suggest we read this question not once, not twice, but multiple times. I often suggest that we can read a probability question and either think we know the answer and jump straight in and go down a wrong path, or we get confused by how many times we're reading it and we just kind of turn off and give up and just put down something and then move on. And we want to be somewhere like obviously in between, okay, where we're thinking it through and just giving our brain time to think it through. So read it a few times. If there's something you can identify, try just mess with it, and then hopefully the complexity of it will come true for you. So if we think what's actually happening here, we're seeing there's 3 attempts. So I could put attempt 1, attempt 2, attempt 3, just to acknowledge that there's 3 things going on. And then go, what's the probability he knocks the coconut for the first time on the third one? Okay, so the coconut being knocked off must be this scenario here. Now, coconut being knocked off was, we were told, 0.34. Of not knocking off is 0.66, or whatever answer you got in part A, part 1. Now, this question is really asking you attempt 1 and attempt 2 and attempt 3. And the probability and means multiply. So you multiply those numbers together, and I have the answer on the next page. Let's just use that. 0.66 by 0.66 by 0.34. So the probability of not knock and not knocking again, and then knocking on the third attempt. Is that multiplication? That gave me this decimal here, which I was told in the questions around 3 decimal places. So I look at the number prior to 3 decimal places, it's less than 5, so the next number stays the same. So I get 0.148. So not very probable, okay, but not terribly. So maybe 14.8% chance if you multiply 0.148 by 100. So this question is a bit of a dose. Now, in fairness, having marked it in the Leaving Cert, it was not well answered, and there's a lot going on here. So let's read the question again. If you have to read it a few times, fair enough. I do. So the figure A, B, C, D, E. Okay, so A, there's the B, C, D, E. So that big, huge shape there, shown the diagram, consists of a large square. Okay, so if you see it here, there's a big square here, and there's going to be a smaller square here. Okay, so it's basically 2 squares kind of laid over each other. It says of a large square ACDE standing on the diagonal AC. That's the diagonal here. of a smaller square ABCF. Okay, so we saw that. The smaller square has a side of length 2 centimeters, and they've shown that there. So if that's 2 there, well, then that's 2 there. Then it says find the area and perimeter of the full figure, A, B, C, D, E. Give your answers perimeter across the 2 different places. So we'll worry about that later on. Now, I would always look at a diagram like this and go, like, what can I know about it? And we say, well, that's 2, so that's 2. Now, if something's a square, it's making 90-degree angles there. Okay, so 90 degrees. If it's a square here, well, that's 90 degrees. That's 90 degrees. It'd be 19 something else, whatever. And that's, I think, all. Now, this image is probably a bit stretched wouldn't look like that on the paper. Because don't forget that ACD is a square. So this length AC, so the length of AC is the same all the way around. Okay. So I think I have a strategy here. If you see it, I'm seeing it here. I'm going to draw it out. It won't look. I'm going to try to keep it looking like the diagram there. It's 90 degrees. That's 2 and 2, and that's a right angle triangle. So Pythagoras will work. So first thing I would do is let's find that length, okay, by using Pythagoras' theorem. So the hypotenuse is the side across the right angle. I can call the other two sides A or B, it doesn't matter which it is. So h squared is equal to 2 squared plus 2 squared. I don't need to put them in brackets because there's no negatives. If you were to use a negative number, always put in brackets because the calculator will have trouble with it otherwise. So 2 squared is 2 by 2, which is 4, plus 2 by 2 is 4. Then finish it off, 4 plus 4 is 8. And then if you're bringing the square root and doing it the more traditional way, if I want to get rid of something, I do the opposite to it. I do it to one side, I have to do it to the other. So what happens there is square root cancels the square, so you're left with h, that's what you wanted. And square root of 8, I can leave it like that. That'd be a big long irrational. So AC there is the square root of 8. So it's there as well, and the square root of 8 over here, and square root of 8 over here. So right there, I have all the sides. Okay, I could do perimeter now if I wanted to. So perimeter is equal to, starting here, 2 plus 2 plus, now I could go square root of 8 plus square root of 8 plus square root of 8. Or I could have done just plus 3 times square root of 8, whichever you want to do it. I'll put that through and I'm going to get 2 plus 2 is 4 plus 3 times square root of 8, because that's what it would be. And that'll be a number. I can use the calculator to do it later on. Now, the thing I was asked them was the area. And if you see the area here, there's the big huge square. Like I can do that area of, like, I suppose, big square is length by breadth. Okay. And that's square root of 8 by the square root of 8. Okay. Because the length of is all the way around. Even though it doesn't look like a square because it's stretched, but it is a square. So you multiply that, it's the same thing as square root of 8 squared. Multiplying something by itself. The square and the square root cancel, you're left with 8. So the big shape there is 8. Now this little triangle here, if you think about it, that's high. I could use a half base by height. Okay. I could look at, well, the full area of that square there is 2 by 2 is 4. I want half that. Okay. I can do it. I'll do it the triangle way. Area is equal to a half base by height. Now the base there, if you look at it from that triangle there, or even this one here, that's the height, perpendicular height. That's the base. So it's a half times 2 times 2. That's a half times 4, which is just 2. So what's the area of the full shape? Well, this one here is 2, and this big shape here is 8. So total area, okay, 8 plus 2 is equal to 10. Okay, a lot going on there. So you had to, I'll go for the answer here. You had to first thing realize that there was a square and a second square, that meant you could find the length of AC because you could use Pythagoras' theorem because it was a right angle triangle because it's 90 degrees. Once you made that leap, you were fairly flying along. Okay. Then you have to realize that when I want to get the area of the big square, okay, and then I did that here, the length by breadth, we showed that, and then when there's that little extra bit, the triangle, it's a right angle triangle, half base by height will work. Or again, you could go 2 times 2, get the full area of the square and just go half it, which in a sense is what this formula is. And did that out, okay, got 2 the area of both shapes is 2 plus 8 was 10, and the units is centimeters squared. Now, the perimeter, we did it there, we didn't turn it to a decimal. And I just reminded myself, we were asked to correct the two decimal places. So when you put that whole calculation there through the calculator, I came up with 12.4852. They said they want that to two decimal places, so it's the 5 here that matters. 5 and greater goes up by 1. That's the number prior to it, so it'll be 12.49. Sorry, it's a typo. It should say 12.49. My bad. Okay, so that's question 2, and see you guys on question 3. Don't forget to subscribe to get access to more playlists.